Share. Okay, so last time we started talking about Gaussian distribution, and we said that Gaussian distribution is a unique distribution and very popular because it happens that we see in many applications. Okay? And the way we describe it is through the density function. We said that the density function looks like the bell-shaped function. The bell-shaped function that looks like the curved header that is centered around the mean, and the variance controls how wide the distribution is. How wide is it? If you have a large variance, this means that you have, for example, this distribution, which means that you have a wide variation around the mean. And if you have a small variance, then you have a small variation, focused distribution around the mean. Okay? And we said that, okay, if you look at it from the distribution, okay, one thing is that as the distribution becomes wider, larger variance, the amplitude, the maximum amplitude becomes smaller. Because there the area under the curve equals total probability of 1. Okay? So if you integrate any of these, you will get area under the curve equal 1, which is the total probability. And this is the density that gives you how is this total probability distributed among the different values. Now, if you look at it from the distribution point of view or the CDF point of view, then basically comparing, for example, the wide one, which was this one, with the other one, which was the red one, for example. Then basically here, you can see, for example, the probability that it's less than, for example, minus 0.4, it has some non-zero probability. But for the red one, the probability that it's less than minus 4, it's almost zero, because it's narrow. Okay? And then we talked about the different things related to the bell shape. Now, today, inshallah, we'll continue with more examples, and not more examples. Before the examples, we'll talk about how to quantify the probability, the probability of any event that has that under the Gaussian distribution. How can we find these probabilities? This is basically. So now, the PDF is given by this. Then the CDF is the integral, right? The CDF is defined by what, Shabab? It's the probability that x is less than a number, right? Shabab, less than or equal small x. So this is the definition of the CDF. So in order to find this, we integrate from minus infinity, sorry, to x of the PDF. Now, putting the PDF that is up here, you will get basically this CDF. Unfortunately, this CDF doesn't have closed form solution, so it doesn't give you a number value. You cannot solve this integral because it's exponential with the square of the argument. We don't have a closed form for that. And because of that, the only way to do it, to find the solution, is to stabilize numerically. Basically, you solve it numerically and just put tables for specific x. What is the value of fx? Okay. Here is an example of the PDF, and here is an example of the corresponding PDF. This is for mu equal 10, the average. The average is 10, and the standard deviation is 5. Okay. Now, so basically the only way is to do a numerical solution and to build tables. Now let's see how can we build the table. So basically, in order to evaluate for specific x, we go with this, right? For specific x means what? Means with a specific average, with a specific variance. Right? So specific x, specific random variable, Gaussian random variable, has a mean or an average and a variance. Then, in order to find fx of any number x, we need to evaluate this numerically. Okay, let's have an example of sigma x squared equal 3 and the mean equal 5. Then fx of x will be given by this. You're just plugging in here 3 for the variance and 5 for the average. Then we construct a table. So simply solve this numerically. Numerically means what? For x, I get fx of x. For x minus 20, I calculate fx of minus 20, and so on. Okay? Now, what do I get? I got a tail, right? Now, if I have a problem with that involves Gaussian distribution with average equal 5 and sigma squared equal 3, I can use this table, right? To find fx of any number. Actually, fx of any number is up here. Probability that x is this time, that number. So here is the probability that x equals this probability that هذه ايش يا شباب؟ probability x less than or equal minus 20, right? And so on. The same thing here. Probability that x less than or equal 6, and so on. Now, what about if I have another problem that has a Gaussian distribution, the same distribution, however, the average is 2 and the variance is 5. I need to do this again, right? Plug in 2 and 5. I get an integral. I go with the numerical solution. I find the table. So, what about if I have another problem with Gaussian distribution, mean equal minus 7 and average and variance equal 100. I need to plug in minus 7 and 100 and do this again and again and again. How many tables do I need? I can't remember tables, right? So because of that, we go with what we call normalized Gaussian distribution. This basically explains the concept here. So in order to solve for this, we define what we call normalized Gaussian distribution. What does normalized Gaussian distribution is? Normalized Gaussian distribution we define for it fx of x, and the normalized means it has an average of 0 and a variance of 1. This is my distribution that I will build a table for. So I will build one table for one Gaussian distribution with this fx of x. It's this integral. Because the mean is 0, as you can see, and the variance is 1. So it's 2 here and nothing, and 1 here. So this is the distribution that I will build a table for. And the table will be called the value of in the table, it will be called f of x. We remove any subscript here. There's no x here. Because it's not for a specific random variable. It's for the normalized random variable. Okay? Now, if I want a specific variable with a specific average and standard deviation, then I make a change of variable. U equal zeta minus a divided by 0. Then, if I do this, I do the change of variable, I get fx of x. It will look like this in the integral form. And now, if you compare this integral form with this, comparing this with this, what do I get, Shiva? How are they related? Fx of x equals this with the change of variable, x minus ax divided by 7. Let me go back again. This is not a good way to build tables because I need to build the table for a specific ax and sigma. This is not practical because simply need infinite number of tables. So now we need to find a way to do it using one table. In one table, a table for what we call the normalized Gaussian distribution with 0 mean and variance equal 1, a standard deviation equal 1. كان ممكن يكون العلماء على شيء ثاني mean equal 2 and variance equal 5 and so on. However, it makes sense to put things around 0 with 1 as the variance. Now, say logic, something like that. Why would I choose two numbers that are different than 0? So now I can solve this integral numerically, and I can build a table showing for every x what is f of x. Okay, and this is only for one Gaussian variable, which is 0 mean and standard deviation equivalent or variance equivalent. Now, suppose that my problem doesn't have 0 mean and standard deviation equivalent. It has 5 as a mean and standard deviation of 2. what do? I make a change of variable. عشان اخذها ارجع هذه to take this to here. How do I do it? Now this is calculus. I make it in order to take this to this. I make a change of variable. Change of variable equals I define u as zeta minus x divided by sigma x. If I do this, then this integral converts into this integral. أو هذا هو نفسه. هذا هو نفسه. هذا شباب؟ طيب الآن if I want to compare what is inside this integral with what is inside this integral, how are they related? You can see that fx equals, sorry, fx of x اللي هو الانتجرال اللي فيه a وال ax وال sigma x, this is equal to f اللي هو هذا الاوريجينال sorry normalized CDF, however evaluated at the change of variable x minus a minus c. واضحة؟ Again, in order to get rid of specific mean and variance, we normalize zero mean and variance. And then we calculated one table for every x. What is f of x? And we remove the subscript x because this is not for the specific value. It's only for the normalized. It's the general. Now, I built this table, one table. Now I want to use this table for another value with the system ax and system x. In this case, the CDF of this random variable x will be equal to the normalized CDF evaluated at x minus the average divided by the standard. Because this is the change of variable that takes me from the normalized to the non-normalized. Now, any question about how did we do this? Clear? Now we can go to examples if everything is clear. Now, this is very important. Yeah, this is always a question in the exams and the table. This is the table. هذا التابل اللي وريتكم إياه. هذا هو التابل. Fine. Doesn't look like one column because of the following. And this table shows the value of fx اللي هو ايش؟ CDF. What is fx؟ اتفقنا عنه CDF or normalized Gaussian random value. So mu here equals 1, so 0, and the standard deviation equals كم شباب؟ 1. This is fx. For x ranging from 0 to 8. We'll see why we stop that. Now, for x equals 0, what is the probability? What is fx of 0? Now, what is fx? What is fx? Again, what is fx? F of x, what is it? Probability that x is less than 0. What is x in this case, in this table? It's the normalized Gaussian distribution with 0 mean and variance equal 1. So basically, it looks like this. The PDF looks like this. It's around the 0. This is x. This is f of x. Okay, without x. So here, it's the PDF for the 0 mean and the variance. So here, mu equals 0 and standard deviation equal 1. What is fx? What does f of x give me? It's the probability that x is less than or equal x, right? What is it? Here, right? If this is x, then this is what this tells me. This is the area under the curve, under the K, and the semi-curve, okay? Right. So now, for x equals 0, what is this area equal to? Half, right? Because it will be half of the curve. Now, for x equal 0.1, it happens to be 0.5398. For x 0.2, this is the number, and so on. But what about if this is 0.1, 0.2, 0.3? What about if I want 0.12? The different columns here show you the different decimals, the second decimal for this, for every one of them. So 0.0, 0, 0.0, 1, 0.02, Well, so for example, if I want the probability, sorry, fx, so the f of 0.15, what is it? 0.15, Shabab. What is f of x? 0.15. So we go 1, and then we stop at 0.15. It will be 0.559, sorry, 0.5596. What about f of 0.29? 0.29, 0.2, and then we go all the way to 9. So it's 0.6141. What about f of 1.62? We go 1.6, and then we go O2. 0.9474, right? What about f of 2.76? We go 2.7, and then 6, right? 9971, excellent. And so on. Okay? So this is the way we read the table. The first column shows you the f of x. And then the next column shows you f of x with the second decimal. But x is 0.3 with the second decimal, whatever showing there. So,
what is the mean? X or
the mean is ax. mu, because in different books we use, sorry for that. ax. الكتب كثيرة نستخدمها as mu. So it's ax. طيب شباب, any question about this? Now, if okay, before we give other examples, right? كم examples? خليني أعطيكم بعض الأشياء. بعض الأفكار. Now, what about, now if I tell you, إذا أسألك سؤال اللي هو probability x is less than or equal 0.25. كم طلعت معنا؟ 0.25 ولا 0.987, right? كم يا شباب؟ 0.5987, right? طيب, now if I ask you another question, what is the probability that x is larger than or equal 0.7? 1 minus. Huh? Larger means what? Means this is it. I'm looking at this. Right? Now this equals 1 minus this. واضحة؟ التيل هذا البوزيتيف equals 1 minus التيل. Sorry. Nice. This tail is 1 minus equals 1 minus whatever the rest here, الباقي اللي هو شو نسميه, خلينا نستخدم لون ثاني. 1 minus all this. واضحة؟ So it's 1 minus whatever here. So this is equal to 1 minus probability of x less than or equal 0.7, which is equal to 1 minus f of 0.7. What is f of 0.7? 0.7 can 0.7580, which will be equal to 0.2 or 2, right? Okay. واضح؟ أي سؤال؟ هذا سؤال ثاني. This is one question. This is another question. But we are trying to relate ايش علاقة هذا الكيرف اللي هنا اللي to the right with whatever to the left. Okay. Now if I tell you what about the probability that ممكن تجيك أسئلة, what is the probability that x is away from the mean by more than 0.2? What is away from the mean? Away from the mean means that x minus ax is larger than 0.5. how to find this. AX في example هذا is 0. So basically, this will be equal to come away from the mean. So basically, I want away from the mean from here and here by 0.5. So this will be equal to, if this is 0, then this will be equal to probability that X is larger than 0.5 plus the probability that X is smaller than 0.5. صح ولا لا? Away from the mean means that this is the region and this is the region. So, and you can find this using these methods. Okay. And you can ask different questions. We have several examples now. But this is just a way, يعني summary of the different kind of tricks you can do. ممكن تسأل تقول لا أربعة. What is the probability that X is within the mean by 0.5? You see, X minus AX is less than 1. You see, basically, the region hand. And you use this.
Why is it when X less than or equal, especially equal to
when هنا؟ شوف الايكوال في الجاوسيان is a continuous random variable. So putting equal or not putting equal doesn't matter because the probability of equality is 0, صح? So it doesn't matter. Like usually you look for equal or not equal in the discrete random variable because this makes a lot of sense. أي سؤال about this table how to use it? تفضل.
This should be written
هذا probability? Why negative?
Second thing. Minus 0.5.
Yeah, minus 0.5. Thank you. Yes. Thank you very much. It's basically yes. Thank you. Yes, I overlooked this. It's not minus 0.5. Thank you very much. Basically, التيل اللي هنا minus 0.5 نازل 0.5 طالع. Okay, so let's have some examples. Now we understand how to use the table. تفضل. The probability that X is less than a negative value? Yeah, excellent. Excellent. Right, let's take this. How to find this? This is the probability of X less than negative value. You have negative value. How to do that? Symmetry. This is equal to come. So this area less than minus 0.5 equals the area which is above larger than 0.5. So this is equal to the probability that X is larger than 0.5. Minus, yeah, 0.5. But what is the probability that X is larger than 1.5? 1 minus probability that X is less than or equal to 0.5, which is equal to 1 minus F of 0.5. So, what is F of 0.5? So it's 1 minus 0.69 come 1.5. How did you do it? Always the easiest way not to make mistakes here is to remember the curve. And what does this represent? F of X represents the area under the curve to the left, whether X is here or here or here. Now the table gives you positive. However, if you have negative, you need to take the image, which is 1 minus. ليش multiply by 2? Yeah, إذا هذه okay. I'm just trying to solve this. The whole problem you need to continue. واحد يسمع الفكرة؟ تفضل. Yeah, that's a point that I wanted to make. Why did we stop at point 3.89? Triple values after 3.8, 8, 87, 88, 89. What do you get? 1. So خلاص, you reach in 0. That's it. So there's no point to go. If you go to 3.9, 3.4, what will become? 1. So there's no need to table more. Great. Right. Now let's have some examples. So this is the Gaussian distribution with X with now, until now, what we did here is all about a zero mean and unit variance. Unit variance means variance one. And we showed you how to calculate for different numbers, positive, negative, different Now let's take examples about non-normalized. You are Gaussian random value with a specific mean and specific variance. For example, this one. Here, AX is equal to 3, standard deviation equal to 2. And I'm interested in finding the fx of, for example, evaluate fx. This is it. Probability that x is less than or equal 5.5. I cannot take 5.5 to the table because the table is about another random value with 0 mean and unit variance. So I need to use the normalization. So I use x minus ax divided by sigma. So it will be 5.5 minus the average, which is 3, divided by 2, which is sigma, not sigma squared. You divide by sigma, Shabab. Not sigma squared, common mistake. Okay? We don't divide by sigma squared, we divide by sigma, x. And then this gives you a point 1.5, 1.25. So fx of x, which is probability that x is less than or equal 5.5, this is equal to, this is fx of x, right? However, this is equal to f, which is the normalized CDX, which is there before. Evaluated at come 5.5 ولا normalized value, which is 1.25. Normalized value by subtracting the average of 3 and divided by standard deviation of 2. Now going 1.25, so what is it? 1.2, and then we go to 5. We see it as here. 0.8944. Okay. Any question? Another example. Now here we have some words, not only numbers. So here we have the clouds above ground is Gaussian random variable. With x, random variable x, basically above the ground, the attitude of the clouds are random variable, represented by random variable. مناطق مرتفعة مناطق منخفضة. They have, this random variable has a distribution with average equal 1,830 meters, 830 meters. And the standard deviation equal 460 meters. So basically looking at the clouds above the ground, you can see that the average of their attitude is 1,830 and the standard deviation is given by 460. Now the question is, find the probability that a cloud is above 2,750. Find that the probability of a cloud is the probability of a cloud being above ground by more than 2,750 meters. This is the question that we are asking. So basically we write probability x larger than 2,750, which is equal to probability 1 minus probability that x is less than that. Now, is the random variable, do we have a table for this random variable? No. So we need to normalize. So we write, so and this is equal to 1 fx at 2,500. So we normalize by subtracting the mean and divided by the standard deviation. Doing this will give you f1 minus f of 2. Now let's go back and see what f of 2 was. What was f of 2? This is 2 بالضبط 0.9773. This is it. Okay. So we write this probability as 1 minus 0.9772, which is 0.0228. So usually if you want to see it in percentage, easier to pronounce, it's 2.3%. So it's 2.3% of the time you will have a cloud above this altitude. Very rare. Very rare. How is that in the web? You will find that a cloud is above this altitude. أي سؤال شباب؟ One minus because we asked what is the probability that a cloud being above this above ground by more than, greater than. So probability x larger than a number is 1 minus probability x less than a number, which is 1 minus fx of that number. And we continue. Any questions about? Okay. Now you can see that you need a table, right? Well, sometimes you don't have a table. So there are some approximations. And this is what we call the Q approximation. Q is another function. تذكر هذا ايش كان؟ هذا كان الشكل كده. This is the PDF. This was the PDF. Then basically fx of x was this. Right? It's the area under the curve to the left of x. Now you can define Q of x, which is the opposite. وهذا موجود Q of x في كتب كثيرة. Or even في MATLAB, where basically I define it as the area under the curve to the right. So Q of x will be this. شو ما باختصار. هتلاقي كتب فيها ال fx وفيها qx. بعض الكتب تستخدم كده وبعض الكتب تستخدم كده. في MATLAB you will find both. Now, so basically the Q function is the integral instead of minus infinity to x, it's the integral from x to infinity. From x to infinity. Okay? Now, luckily, there is an approximation for the Q function given by this. I'm amazed about approximation, you can just calculate it using your calculator. It's 1 divided by blah, 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 blah. Where A here, AX here is the average. Sorry. This is A, is some approximation constants. B is another approximation constant. And this only applies for x larger than 0. Okay? The error is very, very small. It's less than 0.3%. Okay, sure? So this is one way to do it. Nobody is expecting you to memorize this. If I want to give it, I will give it to you. Otherwise, a table will be given. So let's see how approximation is good. So a Gaussian random variable with AX equal 7, standard deviation equal 0.5. Find the probability that x is less than 7.3. So in order to do this, x is less than 7.3 is equal to fx of 7.3, which is equal to the normalized region by subtracting the mean and the divided by the standard deviation. Gives you f of 0.6. If you go to the table, in the table you will find it's 0.7257. If you go with the approximation, it's 0.7264. So the error is in the third decimals. Third decimal. Any questions about Gaussian distribution is okay? How to use the table? Different types. Well, the error becomes higher and higher as you approach the tail. لما توصل للتيل هنا يصير الايرور اكثر لان تصير الاريا under the curve very small. The error becomes larger than that. Okay. So it's not exact, it's approximation at the end, but it's good enough. طيب. Any questions now? طيب send me your attendance please. So the remainder of the class will go to another distribution. So in the coming classes, the rest of this class and the coming class, we'll talk about some discrete random variables, well-known, like the binomial and the Poisson. They are like the Gaussian. You see them in many problems, but different problems than the Gaussian. We will talk about them, we'll analyze them, and to find how to solve questions related to the binomial and the Poisson. And then we'll use some or talk about some continuous random values, uniform, exponential, Rayleigh, and others. Okay? So, first of all is the binomial. تذكروا البرنولي trial? the nullifier when somebody remember the nullifier? What was the nullifier? Two options. Basically, you have an experiment with two outcomes. Head or tail, pass or fail, whatever. Where basically one has a probability of P and the other has a probability of 1 minus P, right? Now, and we asked this question in chapter 1 about, okay, what is the probability that if I repeat the exam n times, what is the probability that I pass K out of n times, huh? Right? And we said that the solution was n choose K, P to the power n, P to the power K, 1 minus P to the power, the rest n minus K. And we explained why did we have this, because the experiments are independent, and hence P is multiplied by P, K times, and so on. Right? And there are n choose K ways that this will happen, K out of n times. Now, binomial distribution or binomial random variable is a random variable that describes such properties. So in binomial random variable, we define P to be any number, it's a probability between any number 0 and 1. And n, a specific number, where basically this is the number of repeating the experiment. So this is number of repeating certain Bernoulli experiments. Okay, and P is the probability of one of the outcomes here. Then, in this case, we say that the PDF looks like this. It's a summation. It's basically a set of impulses. Impulse at 0, impulse at 1, impulse at 2, and so on. Where the length of the impulse here is what? Is the probability that x equals kam? 1. What is this probability spread? It's n choose 1, p to 1, 1 minus p to n minus 1. Here is fx at 1 is what? Is n choose 1, p to 1, 1 minus p to n minus 1. It's a delta at that with that amplitude. At 2, it's another delta with what? With k equal to, here k equal to, and here k equal to. So it will be probability of x equal to, which is n choose 2, p to 1 minus p, n minus 2. And n has to be given a number, and a given number in this case. Okay, this is called binomial density function. We had a random variable that is described here is a binomial random variable. Okay, so I تذكر in choose k. What was that? What did we call this in choose k? Combination. Number of combinations to choose k out of n, which was n factorial divided by k factorial multiplied by n minus k factorial. Okay, so basically, if you look at 6 here, it's the probability that x equals 6, which is found by the same n choose 6 and so on. Now, if you look at the cumulative distribution function, CDF, it will be the same as the PDF, but step functions. Because you remember in discrete random variables, we said that the PDF is a series of impulses, right? While the CDF will be the integral of these impulses, which is a series of, it's a stair type function, or a series of shifted step functions added together. So basically, we start at 0. This is the probability. It's a jump at 0. So probability x is this then. Can a binomial random variable be a negative? Can you have the probability that you pass the exam minus 2 times be negative, or finding a head after pressing the coin 10 times? Can you have number of heads equal minus 5? So basically, the newly random, binomial cannot have 0. So it's always 0. And you will never find anything at 0 before 0 in the PDF or CDF. And usually starts at 0 and then keeps accumulating. ايش هذه كانت الستيب اللي تتذكر؟ What was this step equal to? Probability of what? X equal 1. Yes. The jump at any number is the probability equal to the probability that X equal that number. Same thing for this. Okay. One thing that I probably forgot to mention about the naming. Density function, right? Well, in discrete random variables, there are many books that call it probability. It's like another name, mass function. This is another name for the PDF. PMF. Only in discrete random variables. Because it looks like a mass وزن مقسم على ثلاث نقاط. It's called probability mass function. مرات يسموها probability mass function or يسموها probability density function, but you need to understand that it carries two names, PMF, PDF. However, PMF only applies for discrete. You cannot say PMF for continuous. So, any question about the description? Now, when do we apply binomial? When you have a Bernoulli trial with two outcomes. One has a probability of P, another has a probability of 1 minus P. Like games of chance, win or fail, detection, target, no target, exam, pass, fail, hit, tail, whatever. And you ask this question of, out of the n trials, how many case successes out of n trials? This is what the probability is given. And this is what we said equal n choose k, probability of k, 1 minus probability of k. Okay? Go ahead. Thank you. Yes, n minus. N minus. Thanks. N minus. Thank you. Now this is a MATLAB example. Just go over. Let's have one example and then we'll close. So basically, here we have a canned juice company. Basically, it tells you that there is a promotion. If you open a can, there's a probability that you find applies. Whatever. So under the cap promotion, whereby you win an instant cash prize of 1 real if you find the can, if you open it and you find this 1 real. And the probability of having this is 1 over 4. How do we know this probability? How do we know that the probability of having anything under the cap is 1.1 over 4? شركة basically من خط العصير هم عارفين ان ربع العلب فيه basically. So basically this is by design. Find the PDF, or we call it a PMF, for the number of winning bottles donated as n, as x. So what is it? Probability of x, p of x of k equal, or if sorry. This is basically probability. اسمها probability that x. We are just using short notation here. This is equal px of k. It's equal 8 choose k, 1 over 4 to the power k, 3 over 4, which is 1 minus p to the power 8 minus k. And if you just lump them together, you find that. Simplifying them, you will get this. And if you put the PDF, it will be series of deltas at k, at different k, and the probability that x equal k is x, multiplied by every delta. And the question, compute the probability that you win more than 4 reals. What is the probability that you win more than 4 reals? How to find it? More than 4 reals. مش equal 4 reals. Equal 4 reals, probability x equal k, which is this. 8 choose probability x equal 4. 8 choose 4 and so on. So, however, more than 4 real, what is it? What is it equal? 5 plus probability of 6 plus probability of 6, 7 and so on. So basically you sum from 5 to 8. Of 8 choose k, 3 to 8 minus k. Or you can do the find هذه اسهل لانه هذه يسم 5 6 7 8. الثانيه تعطيك you need to sum for 4 3 اكثر من واحد. Okay? I think the time is up. So next time, inshallah, we'll start the poison and close that. Thank you.